Deviation from ideal pump theory. The actual pump head data differ considerably from the ideal theory. Take for example consider this picture again for a description. For example, for the pump, as shown the diagram of the option here as inch pump at the revolution per minute as shown here. The theoretical shut-off head is H0 ideal which is we have the pump angular velocity multiply to convert to the radian on second multiply to the R, which is in inch, in foot, a square, also a square here, and multiply to divided to the gravitational acceleration. The ideal theoretical shut-off head is from this picture at Q is 0. We believe the actual shut-off head for the only this point about from the diagram we have where Q equals to 0 shut-off head pump from diagram is approximately 670 feet or 61% of theoretical value. This is the about 30% of the theoretical value. This is the sharp drop-off and is indicative of non-recoverable loss of 3 types. Non-recoverable due to the first one is imperial recirculation route. Significant only at low flow rate. Friction losses on the blade and passage surface. On the blade and passage surface. Which increase monotonically with flow rate. And the last one is shock loss. Due to the mismatch between the blade angles and the inlet flow direction. Mismatch between the blade angles and the inlet flow direction. Especially significant at high flow rate. These are complicated three-dimensional flow effects and hence are difficult to predict. Although I mentioned numerical CFD techniques are becoming more important, modern performance prediction is still a blend experience, empirical correlation, ideas theory, and CFD modification. Dimensionless pump performance is the next section and will describe in the next video part.